Hello everyone and welcome back to my YouTube channel. Today we are discussing the solution of the end sem paper. I have the question paper here. We are going to give solution for the case study part. The complaint says that theft of a mobile phone by an unknown person at MG Road on 2023-02-20. The phone was stolen when he was shopping at a store. The thief was wearing a black jacket and had a scar on his face. Based on the above complaint and context, now we are going to answer these following questions. We are starting with question number one. Question number one says that how can unstructured data, such as text from written complaints, be analyzed in the context of computer science? Provide a detailed example of a data mining activity that could be employed to analyze unstructured text data. Solution of this question is first, analyzing unstructured data. Unstructured data is data that does not follow a predefined format or organization, such as written text in complaints, emails, or social media posts. Analyzing these data require applying techniques from natural language processing (NLP) and text mining to extract valuable information. In the context of written complaints, the goal is to first, pre-process the text for analysis. Second, extract meaningful information such as crime type, location, and date. Third, classify the complaints into relevant legal categories such as IPC or BNS sections. Second step is to analyze unstructured text data. Now we are going to analyze the unstructured data that we have got. First is text pre-processing. The text pre-processing includes tokenization, which means split the text into smaller units such as words or sentences. Second, stop word removal. Remove common words. Example is the and do not add meaningful value. That do not add meaningful because is and the they are the common things. We can understand it without if they are present only. Stemming or lemonization. Reduce words to the root form. Example, stone converted to steel. The root form of the verb. Especially the verb. Named entity recognition. NER. Identify entities like locations, dates, and people mentioned in the complaint. Second is feature extraction. Convert textual data into a numerical format using techniques such as bag of words (BOW) means represent text as a set of word frequencies. TF and IDF, term frequency inverse document frequency, which means weight important words in the text while ignoring common words. Word embeddings, word to vec, which means to capture semantic relationships between words. Third is of text mining and analysis. Extract patterns or relationships from the text using clustering or classification algorithms. For example, cluster algorithms into complaints into categories such as theft, assault, and fraud. Third is the example of data mining activity. Consider the following complaint, the complaint which I have given. Step-by-step process is first text pre-processing, tokenized text, theft, mobile phone, unknown number, person, MG Road, 2023-02-20, which is the date, and then black jacket, then a scar on his face. These are the tokenized text. It means we have splitted the text into small words that can be identified. Remove stoppers. Now the stoppers like theft, mobile phone, and the is and of they are to be removed. Then named entity recognition. Extract entities like crime type, theft, location, MZ road, date 2023-02-20. Now second is feature extraction. Apply TF-IDF to represent the words numerically. Word TF-IDF, then we have to apply TF-IDF like theft to 0.5, mobile 0.2, M0 0.3, jacket 0.1. We have applied it. Now third is classification. Use a pre-trained classification model to predict the category of the complaint. Example, theft. Map the category to the relevant IPC section. Example, IPC section of 378 for theft. We are classifying what kind of theft or how it relates with the IPC section. Fourth is automated mapping. Use rule-based logic over trained model to recommend applicable legal sections. The category like theft, IPC section 378, automated mapping. Mapping has been done, that is IPC section has mapped to the theft, which has been done by the in the complaint. Now, fourth is benefit. We talk about benefits of data mining for that text analysis. First is it automates the identification of relevant categories and sections. Yeah, second is it reduces the manual effort in processing complaints. Third is it improves the speed and accuracy of legal classification. This approach enables data scientists to extract actionable insights from unstructured complaints, making it easier to analyze and classify text for legal or organizational use cases. Now we are moving to question number 2. How can text mining techniques be applied to automate the classification of written complaints? Solution of this question is text mining techniques can automate the classification of written complaints by leveraging natural language processing and machine learning methods to extract insights, identify patterns, and map complaints to predefined legal categories. Example IPC or BNS sections. The automation involves transforming unstructured textual data into structured formats that can be analyzed and classified effectively. First step is to automate classification using text mining techniques. First is data collection. Collect complaint data from sources such as legal databases, customer grievances system, or written records. Second is text pre-processing. Pre-processing is essential to clean and prepare raw text data. The steps include tokenization. Split text into smaller units like words or phrases. Example: theft of phone is to be categorized into theft and phone and off and phone. Stop or remove. Remove common text words that cannot contribute to classification, such as is, the, is, and. Lemmatization or stemming convert text to the. We are talking the facts that we have talked about, the feature extractions, the model stemming and training, text classifications, and then rule-based mapping optional. Means if you have done the text classification, then it comes under the rule-based mapping. And evaluation and deployment. Second is the example of application. It's the same that we have done in the above section only. Benefits of a text mining technique: scalability, it handles large volumes of complaints efficiently. Accuracy, it reduces human error and ensures consistent classification. Speed, processes complaint faster than the manual analysis. Insights, extracts actionable data for legal decision making. By applying text mining techniques, organizers can streamline complaint processing, improve accuracy, and ensure compliances with legal frameworks. Now we are moving to question number 3, which says that discuss specific methods or technologies that facilitate the automated classification of complaints, such as NLP, text classification algorithms, and machine learning models. Automated classification of complaint involves leveraging a combination of natural language processing, text classification algorithms, and machine learning models to process the categories unstructured text data. Below is a discussion of specific methods and technology that facilitate this process. One is natural language processing techniques. NLP provides the foundational tools and methods for understanding and processing human language. Key techniques include first, text preprocessing, tokenization, stop-word removal, stemming, and lemmatization. And the second includes named entity recognition. Means crime has been done, the theft has been done, then location MG Road, date at 2023 0220. Part of speech tagging is to identify the grammatical role of each word. Example: noun word to better understand sentence structure and context of the structure. Now we are moving to word embeddings. Use embeddings like word to wake, groovy, or BRT to represent words in a way that captures semantic meaning and relationships. Now in the second, we are moving to the text classification algorithms. Text classification algorithms form the core of the complaint classification process. These algorithms process the numerical representation of text and classify them into predefined categories. First is rule-based algorithm. Use predefined rules or patterns to classify complaints. For example, keywords like stolen or robbery can map to theft-related sections. Second is machine learning-based algorithm. NaiWise, a probabilistic model that works well for text classification by calculating the probability of a complaint belonging to a category used on word frequencies. Second, it supports vector machines. Support vector machine, a powerful algorithm for support separating text data into categories using hyperplanes. Decision trees and random forest. Tree-based models that classify complaints by learning decision rules from training data. Third is deep learning models. Recurrent natural neural networks capture sequential dependency in text, making them suitable for longer complaints. Now we are moving to techniques and tools that can be used. First is NLP libraries. NLTK Natural Language Toolkit, which provides tools for tokenization, stemming, and text analysis. PASI, a fast NLP library to tasks like NER, dependency parsing, and POS tagging. Hugging Face Transformers offers state-of-the-art pre-trained models like BERT and GPT for text classification. Machine learning frameworks like SCI-KT learn a versatile library for implementing NaiVibe and all these things. Text vectorization tools, we have TF5, TF vectorizers, word embedding models. And we have cloud-based solutions, which include Google Cloud Natural Language API, AWS Comprehend, which you all know about that. Example of a flow of a complaint classifier. First is input text. Theft of my phone by an unknown person at MG Road on 2023 0 to 20. Pre-processing includes tokenization, stop, first remove, and ER to extract key entities. Then feature extraction and classification, and then output, the output which you get. So the benefits of the technology, scalability, accuracy, automation, and context awareness, which we have talked earlier. Now we are moving to question number 4, which says that refer to the sample complaint, the complaint that has been given, and then describe the approach, algorithms, or processes that could use to identify the applicable IPC or BNS section for legal classification. We have to talk about legal IPC sections and BNS section that approve to the complaint. We have crime type like theft, object stolen, mobile phone, location MG Road, date 2023-020, suspect's description, wearing a black jacket and had a scar on his face. These are the description of that crime that has been done by the criminal. This information will be used to classify the complaints under relevant IPC and BNS sections. Step-by-step approach. First is text pre-processing, what we have talked about it, and we will be used to take feature extraction. We will extract features from the techniques like the TF-IDF, which is term frequency, inverse document frequency, which quantifies word sentence to the context of the complaint. Then we will use word embeddings. Then we will move to the classification. It is the important technique. Here we use NaiVives or support vector machines, decision tree, random trees, deep learning models, RNA and LSTM. Then we use transformers. We can use transformers also here. Then training data, we use historical complaints data labeled with corresponding IPC sections, like 378, section 378 for the theft. Step 4 includes rule-based mapping, which is optional. Complement the machine learning model with rule-based system to ensure accuracy in specific scenarios. For instance, keywords like theft, stolen, or robbery directs maps to IPC section 378. Step 5 is mapping to IPC BNS sections. After the model predicts the categories, map it to the relevant legal section using the predefined directory. Algorithms and techniques, text processing and AR. They use libraries like SPACY or NLTK for text processing and entity recognition. Second is feature extraction. Employ the TF-IDF vectorizers or embeddings like BERT using frameworks such as Hugging Face. Rule-based mapping, which includes to build a mapping layer using regular expression or keyword-based rules. We have given the example that we have talked about in the earlier section. You can look after it if you want. Then we are moving to the conclusion one, that by combining NLP techniques, machine learning models, and rule-based systems, the process can effectively and easily classify complaints and map them to the relevant IPC sections and accordingly we can do. Now we are moving to question number 5, which says that what steps would you take to analyze the complaint and recommend the appropriate IPC or PNS section related to the crime? What steps you can take? First is to understand the complaint. Again, complaint is you have to understand it, then to analyze the complaint, data bit processing, and all these things, stop word removal, stemming, elimination, normalization. Then we will move to information extraction. We will extract information that meaningful information that is relevant for our case. We will extract the information by the name and entity recognition. We will recognize the entity which are useful for our further processes. Contextual analysis. Context, we will match the context which words are context based. Then we will use the classification of crime, what type of crime has been done, what is the level of that crime. Then we will use the feature extraction, machine learning, deep learning models like naive support vector machines, deep learning models. Then we will use the predictions. The model predicts the category of the crime as theft. Now we are moving to step 4, which is legal mapping. Map and predict the crime category to the relevant IPC or PNS sections. Rule-based mapping. Use predefined rules or keywords matching. Example, keywords like theft, stolen, or robbery map to IPC section 378. Database KG. Cross-reference with a database of IPC PNS sections to verify the applicable law. Now in the step 5, we will generate output, provide a structured recommendation map section like IPC 370 and explanation theft of movable property is covered under section 378 of the Indian Penal Code. And then we are moving to the steps of continuous improvement, update model training, refine rule-based mapping, feedback loop. Now we are moving to question number 6, which says that what structure and algorithms are stable for addressing the task of classifying complaints into relevant legal section are described in the previous section. To classify complaints into relevant legal section, it is essential to use appropriate data structure and algorithms for efficient processing and accurate classification. Below are the details. First is data structures. The choice of data structures depends on the nature of the task, which involves storing, processing, and retrieving information effectively. Text representation, bank of words, then the TF-IDF, then word embeddings that can be done, then sentence embeddings. Models like BERT or sentence BERT generate embeddings for entire sentences or paragraphs. Use of it is for the suitable or for more complex complaints where the overall context matters. Data structures for mapping retrieval is hash maps, which is dictionaries use of mapping keywords to IPC and BNS section. Example, theft 378, man murder 302. Use efficient for lookups and rule-based mappings. Then we use the prefix tree, which tree efficiently stores and sets for keywords or phrases related for legal section. Example, tribe storing crime-related terms like theft, robbery, assault. This uses ideal for it is ideal for keyword-based classification. Then we use graphs which represent relationship between crimes, legal section, and keywords. Example nodes, terms of crimes and ages showcases its IPC mapping that will be done. Use of it is to visualize the transverse relationship in complex cases. Then we have algorithms, which we have already talked about, stemming and all this elimination. Then we have naive from machine learning algorithms. We use naive and second support vector machines. Random forests, deep learning algorithms like recurrent neural networks, transformer models, rule-based algorithm, which includes regular expressions, keyword matching, workflow using these data structures and algorithm, input complaints, pre-processing, classification and algorithm, mapping, output, and we are going to the conclusion part. Then question number 7, this says explain how these data structures and algorithms would work in practice to ensure the complaints accurately categorized into the correct IPC or BNS section. Answer of this question is to ensure accurate categorization of complaints into the correct IPC and BNS section. The described data structure and algorithm work together in an integrated pipeline. Here's a practical explanation of how they function. First is the overview of the system workflow. The system processes the complaint text using the following key steps. First is input complaint. Input complaint. Accept the unstructured text. You have to first accept the unstructured data. Then only you can convert in the structured data and extract the meaningful information from that data. Then second is pre-processing. Convert the text into structured and analyzable format. Third is feature extraction. Represent the text numerically for model consumption. Then fourth is classification. Predict the crime type or legal categories. Fifth is legal mapping. Map the crime categories to the corresponding IPC or BNS sections. Sixth is output. Provide a recommendation with a predefined legal sections. Second is the implementation of data structure algorithm. Step one is text processing, data tokenization, hash maps, algorithms that can be used is tokenization, addresses, stop word movers, stemming, lemmaization. Then we use the feature extraction. The purpose of this it is to convert the clean text into the numerical representation for machine learning models. Data structure used is TF-IDF vectorization, word embeddings, TF-IDF algorithm, embedding models, and etc. 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 Then we use the text classification, which is data structure used like training data classification models, algorithm used like NAVWIPE, and all these things support vector machines, transformers, legal mapping, and all these things. And after that, we move the algorithm use that is keyword matching, database queries, output generation like uh, purpose of what it is. In data structure use like first in data structure output format, a dictionary to store the results. For example, JSON can be used for the crime is equal to theft, legal section IPC 378 details, and an object like phone, location, algorithm use. Serialization, which is to convert the structure results into a readable format. Example, JSON, these are the meaningful structures. Practical example of the workflow input classification, feature extraction. We will extract the features in the legal mapping and output on all ensuring accuracy. Training, it ensures accuracy. First is training on high quality data. Use a comprehensive data set of compares and legal mappings. Regular model updates retain the classification model with new complaints and evolving legal codes. Third is feedback classification. Now we are moving to question number 8, which says that what matrices are appropriate for assessing and the performance of the algorithm used in text mining for classifying complaints. To evaluate the performance of algorithms used in text mining and classification complaints, specific matrices are essential to assess the effectiveness, accuracy, and reliability. These matrices can be categorized into classification performance matrices and model evaluation matrices. First is key matrices for text mining and classification. First is that accuracy. Definition: the ratio of correctly classified complaints to the total number of complaints. Formula is text accuracy equals fraction of text number of complaints prediction, text total prediction. Use cases measures the overall correctness of the model. Second is precision, the ratio of true positive correctly classified complaints to the total number of predicted positive. It uses cases like to indicate how well the model avoids false alarms. Example, wrongly classifying a complaint into a legal section, it doesn't. It ensures the precision of your mapping. Recall, which is sensitivity, the ratio of true positives to the total number of actual positive. Its use cases is to avoid, so the ability of model to identify all relevant complaints for a legal section. The limitation of it is that of record is that it may prioritize detecting all true cases at the expense of precision. F1 score, which is this is the harmonic mean of precision and recall, providing a balance between the two. Use cases is too useful for them for there is to trade off between precision and recall, particularly in imbalanced data sets. Then we are moving to confusion matrix, which says that a table used to visualize the performance of a classification model by showing true positives, false positive, true negatives, and false negatives. Use cases helps to in understanding the distribution of errors and correct the predictions across all cases. ROC curve and AUC, which is area under curve. ROC curve which says that a plot of the true positive rate against the false positive rate for different classification thresholds. AUC, which is the area under the ROC curve. A higher value indicates better model performance. Use cases to evaluate the model's ability to differentiate between classes. Log loss measures the uncertainty of prediction by penalizing wrong confident predictions. Use case is useful for probabilistic models. Naive model evaluation matrices specific to legal classification. Class imbalances matrices. Balance accuracy. Adjust for imbalanced data sets by averaging recall across all classes. Use cases like ensure fairness in the classification of rare crimes or underrepresented IPC BNS sections. Misclassification rate definition is the percentage of complaints that have incorrectly classified. Then we move to the precision recall and all this we have discussed F1 scores and also. Then we move to question number 9, which is the discuss the effectiveness and accuracy of text mining techniques using matrices such as precision recall, F1 score, and confusion matrix. How would you evaluate the success of classification model in correctly identifying the relevant legal sections? The solution of this question is the effectiveness and accuracy of text mining techniques for classifying complaints into relevant legal sections and are measured using performance matrices like precision, recall, F1 score, and confusion matrix. These, these matrices these matrices evaluate how well the classification model distinguishes between different legal categories and identifies the correct legal section. First is matrices to measure effectiveness, precision. Then we have a recall. And we get to move into the F1 scores that can be used in confusion matrix and the significance of an example of scenarios like classifying complaints into legal section. Input complaint, my wallet was stolen while working in the market. Actual label is IPC 378 for theft and IPC 378, which is the correct one, predicted label. Matrices calculation that it also includes that one. Then criteria for success, high criteria and recall, low misclassification rate, F1 score for balancing trade-offs, consistent results across classification. The uh, conclusion to the solution part of question number 9 is the effectiveness of text mining machines for classifying complaints into legal sections can be evaluated using precision, recall, F1 score, and confusion metrics. These matrices provide a comprehensive understanding of the model's ability to predict the correct legal sections. A successful model will have a high precision and recall, a balanced F1 score, and a confusion matrix with minimal errors. Regular evaluation along with feedback loops ensure continuous improvement in accuracy and reliability. So here we have discussed the all question 9 questions that has been talked in this case study. We have completed all these 9 questions given in the question paper. Uh, as you have all have demanded that I should prepare a solution for the answer paper, I have prepared a whole long and explained detailed solution for this case study. I hope you all would have liked the solution part. It was a very hectic work, but I have done it for you. So I can expect like and subscribe from you all if you have liked this video, and I ensure that I will continue to prepare such videos, such knowledgeable videos on data science for you in further days also. Thank you for watching my video. See you soon.